In the heart of galaxy M87, 55 million light-years from Earth, lurks a gravitational monster so massive it bends reality itself. M87 Cox, weighing 6.5 billion times more than our Sun, devours light and shoots plasma jets 5,000 light-years into space at nearly the speed of light. This cosmic predator harbors secrets that challenge everything we know about physics. We'll journey to the edge of an abyss where time stops and explore jets traveling faster than anything should move. Like and subscribe as we peer into ultimate darkness and discover why this monster might hold the key to understanding reality itself. What happens when you fall past the point of no return? And how does this invisible giant control the fate of trillions of stars? Prepare yourselves. We descend into the abyss. M87 makes our Sun look like a grain of sand next to a basketball. This supermassive black hole's event horizon stretches 120 billion miles across, nearly 4 times the distance to Neptune. If it replaced our Sun, Earth, Mars and Jupiter would all be inside the point of no return. The monster weighs 6.5 billion solar masses, compressed into a region smaller than our solar system. This creates gravity so intense that it doesn't just bend space, it stops time itself at the event horizon. A clock there would literally freeze from our perspective, creating a moment that lasts forever. But M87X isn't just sitting quietly in space, it's actively feeding, devouring entire star systems, and growing more powerful with each cosmic meal. When matter falls toward this beast, it creates one of the most violent phenomena in the universe, an accretion disk that burns brighter than 1 trillion suns. The disk forms as doomed material spirals inward, like water down a cosmic drain. But this isn't water, it's matter moving at 30% light speed, heated to 10 billion degrees by friction between different orbital layers. The result is a disk that outshines entire galaxies, visible from billions of light-years away. The inner regions experience conditions more extreme than stellar cores. Temperatures reach levels that shouldn't exist outside the Big Bang's first moments. Matter is torn apart at the atomic level, creating a plasma so energetic that radiation pressure nearly equals gravitational attraction. Magnetic fields threading through this chaos become wound up like cosmic springs. When they snap and reconnect, they release energy equivalent to billions of nuclear bombs, creating flares that can brighten the entire system by factors of 10 in just hours. Some material escapes this gravitational prison through the most spectacular mechanism in nature: relativistic jets that challenge everything we thought possible about physics. The jets erupting from M87Cs represent nature's ultimate blowtorches. These narrow beams launch matter at 99.5% light speed across distances of 5,000 light-years, farther than from Earth to the nearest stars. They carry more energy than our Sun will produce in its entire lifetime. The jets form through magnetic field lines that tap directly into the black hole's rotation, extracting energy like a cosmic dynamo. This process is so efficient, it converts up to 42% of matter into pure energy, making nuclear fusion look primitive by comparison. At these extreme speeds, time dilation becomes dramatic. A clock moving with the jet would run 7 times slower than ours. Years pass like months for particles racing through these cosmic accelerators at nearly light speed. The jets maintain their focus across thousands of light-years through magnetic confinement and relativistic beaming. From Earth, we're looking almost straight down the barrel, which explains why M87's jet appears so bright in radio telescopes. As the jets plow through space, they create shockwaves that heat surrounding gas to millions of degrees, forming radio lobes larger than entire galaxies. These cosmic cavities glow for millions of years, marking the black hole's presence across vast distances. The jets also accelerate cosmic rays to energies beyond anything in human particle accelerators. Some of the most energetic particles ever detected may have originated in jets like these, traveling billions of years through space before hitting Earth's atmosphere. But perhaps the most mind-bending aspect of M87X involves what happens when you actually fall toward it. Imagine approaching M87K from a safe distance. The black hole appears as a dark shadow against the brilliant accretion disk, like a cosmic eclipse frozen in time. But as you fall closer, space-time warps in impossible ways. Light gets bent around the black hole, creating multiple distorted images of the same objects. You'd see the back of the accretion disk above, below, and around you as photons follow curved paths through twisted geometry. Time dilation becomes extreme near the event horizon. To outside observers, you appear to slow down and redshift until you fade from view, frozen at the boundary forever. But from your perspective, you cross the event horizon in normal time, feeling nothing special about this ultimate point of no return. Inside, space and time literally swap roles. The singularity at the center isn't a place, but a moment, like tomorrow becoming inevitable. All paths lead inward, upward toward a point where density becomes infinite and physics breaks down completely. The tidal forces would stretch you vertically while compressing you horizontally in the grim process called spaghettification. For smaller black holes, this would be violent and immediate. But M87T's enormous size means these forces are relatively gentle near the event horizon. At the singularity, matter gets crushed to infinite density and space-time curvature becomes infinite. Our equations literally divide by zero, producing meaningless results. We simply don't know what happens here because current physics becomes useless under such extreme conditions. Some theories suggest quantum effects might prevent true singularities, creating exotic objects made of quantum foam. Others propose that black hole interiors might connect to other regions through wormholes, but these remain pure speculation with no observational evidence. What we do know is that crossing the event horizon is absolutely one way. Even light cannot escape because there are literally no outward directions available inside. Space itself becomes a cosmic trap where all paths lead to the center. This imprisonment of light creates the black hole's defining characteristic, its absolute darkness that hides the most extreme physics in the universe from outside observers. M87 doesn't exist in isolation. It sits at the heart of a galactic ecosystem spanning millions of light years. The supermassive black hole and its trillion-star host galaxy have evolved together through complex feedback processes that regulate cosmic evolution itself. Galaxy M87 contains 10 times more stars than the Milky Way, creating a gravitational well that traps intergalactic gas and heats it to tens of millions of degrees. This hot atmosphere would normally cool and form new stars, but M87T's jets prevent this through radio mode feedback. The jets inject enormous energy into surrounding gas, creating bubbles that heat material above star formation temperatures. This effectively sterilizes the galaxy, shutting down stellar birth for billions of years. The black hole has throttled its own food supply through its own activity. This creates cosmic balance. If the black hole becomes more active, it heats more gas and reduces star formation. But less star formation means less material falling inward, reducing black hole activity. The system naturally self-regulates. M87 dominates the Virgo cluster, 1,300 galaxies bound by gravity. Smaller galaxies orbit around it, occasionally getting torn apart by tidal forces in a process called galactic cannibalism. Their scattered stars merge with M87's outer halo. The jets carve enormous cavities in the cluster's X-ray atmosphere, creating holes that persist for millions of years. These bubbles distribute heavy elements throughout intergalactic space, enriching the medium with carbon, oxygen, and iron, essential for future planet formation. Recent observations reveal that M87T's activity varies dramatically over days to weeks, suggesting the accretion process is highly chaotic. The relationship between the 6.5 billion solar mass black hole and its trillion-star galaxy demonstrates a fundamental principle. Supermassive black holes and galaxies grow together through intimately connected processes. This cosmic symbiosis extends beyond individual galaxies to influence universal structure evolution. Black holes like M87 serve as cosmic thermostats, regulating temperature and star formation throughout the largest bound structures in existence. Looking toward the future, M87 tech will continue growing slowly, accreting about 1 Earth mass daily. Over billions of years, galaxy interactions could dramatically increase feeding rates, potentially transforming M87 Khan into a brilliant quasar, outshining the entire observable universe. The most dramatic change would occur during galaxy mergers, when two supermassive black holes spiral together and merge in collisions that create gravitational waves detectable across billions of light years. Such events will become common as cosmic structure continues evolving, but on the longest timescales, dark energy and accelerating expansion will eventually tear apart galaxy clusters. M87 might find itself alone in an increasingly empty universe as other galaxies recede beyond the cosmic horizon. Without material to feed on, the black hole would gradually evaporate through Hawking radiation, quantum effects that cause black holes to slowly lose mass. However, this process is incredibly slow. M87 would take 10 to 100 years to disappear completely, a time span that makes the universe's current age seem instantaneous. Until then, M87 TAS continues serving as nature's most extreme laboratory, testing fundamental physics under conditions impossible to recreate elsewhere. Each observation reveals new complexities about black holes, relativity, and the deepest workings of reality. Future space telescopes will provide even more detailed views near the event horizon, potentially resolving questions about quantum gravity, information paradoxes, and the true nature of spacetime itself. The monster that once seemed purely destructive is now recognized as fundamental to cosmic evolution. M87 regulates star formation, distribution, distributes heavy elements, and creates spectacular phenomena while serving as a window into physics beyond current understanding. This gravitational leviathan reminds us that the universe contains forces far beyond human experience, yet through science we continue peering into ultimate darkness and emerging with new knowledge about our cosmic home. M87 waits at the edge of known physics, challenging us to push the boundaries of human understanding ever deeper into the mysteries of existence itself.